Earth now versus a century ago, a stark contrast. Humans have enveloped our planet with an abundance of space debris. According to recent research, most wide-angle images now show orbiting debris. Looking ahead, more satellites hinder astronomical observations. Today, clearing crowded near-Earth orbits is a top challenge for space exploration and astronomy. Earth is circled by space debris. Scientists track them. Over 11,000 active satellites and debris clutter Earth's orbits. Troublingly, many satellites operate with unclear oversight. Thousands of unlicensed vehicles were roaming around your neighborhood, completely unchecked. Thousands of plateless cars near your home daily. And you have no idea who the driver is, where they're going, or what's inside the vehicle. This uncertainty is now playing out above our heads in space, and the problem is rapidly escalating. For example, SpaceX is deploying the world's largest low-Earth orbit satellite communication system, known as Starlink. Its plan, launch over 40,000 satellites. This number exceeds all launched satellites. May 2025, 8,514 satellites in orbit. More concerning, some satellites are designed to be invisible, evading detection. Satellites use tech for invisibility, crafted with special materials. To minimize radar cross-sections, nearly undetectable. So how can we locate these deliberately hidden satellites? Traditional methods have significant limitations. Radar detects reflections from satellites. Stealth satellites scatter signals, reducing their apparent size. Some are invisible, others are spotted via sunlight reflection. But this approach only works during twilight, when sunlight reaches them, while the sky remains dark enough. Satellite reflectors fail this technique. US and USSR launched stealth spy satellites. To this day, more nations use satellites for military intel and secure comm. They increasingly wish to remain hidden, making it a game of hide-and-seek in space. How do you track an elusive satellite amid national security stakes? In modern astronomy, stellar occultation is an effective observation method. A silhouette passes by the screen. This phenomenon occurs when a satellite passes between a star and us, temporarily blocking part of the star's light. Astronomers call this an occultation event, and what's truly remarkable is that researchers developed a method to analyze light dimming, revealing satellite shape, allowing them to determine whether a satellite uses a single-core design or a more compact square design. This technique identifies hidden satellites, designed in radar-invisible stealth shapes. Researchers tested with 100K virtual satellites, accurate shape recognition. Establishing satellite ID faces challenges. Technical requirements are strict due to satellite speed, up to 7.9 km/s. Blocking starlight lasts seconds, captures rare. Cameras shoot hundreds to thousands of FPS, requires dense star fields along the path. With tens of percent, hundreds of stars for lensing analysis. Currently, most telescopes lack needed speed and sensitivity. This technique only works when the satellite is in Earth's shadow, if it reflects sunlight. Researchers conclude it will obscure background star brightness changes. Their method exceeds current optical system capabilities. They remain optimistic about standardizing this tech. Scientists fear SAT detection tech interference impacts sky views. Up to 30% of images from Vera C. Rubin Observatory will be affected by satellite trails. It disrupts observations and harms studies. It harms long-term sky surveys. It may miss threats when searching. Astronomers observe distant galaxies, exoplanets, and gravitational waves, crippled by satellite interference. Therefore, IAU collaborates with satellite operators on dark satellite tech. Minimize satellite interference to clear Earth's orbit. Ensuring every star's light can reach human eyes unimpeded.